Okay, and we're live. There we go. Okay. So it is time to go back to learning to code. Okay. Let me just share on LinkedIn and Twitter, and we should be on our way. There we go. Okay, it's done. Well, I just wake up from my slumber. I was oh wait, what? Oh, it should be working. There we go. So I went back to eat. I ate something. I got very sleepy because I was playing Risk StarCraft yesterday up until 3 a.m. So I was feeling very sleepy after eating, so I went to sleep. I just wake up. I realized that it's already 8 p.m. Central Standard Time. And I said that I was going to continue studying Python. And then I'm going to study Pandas because I do have a job and I want to get rid of Excel. I hate Excel. Okay. Okay, it's weird that this is here. Okay. So I just completed section 7, Advanced Python Functional Programming. And now we are going to continue. I'm going to continue on Decorators. So let's see what's that about. I had to say that Python is a very clean language and does have the ability to jump back and forward between functional programming, structural programming, and object-oriented programming. And I think that it doesn't seem to be a way to limit that. And I don't think the idea is to encapsulate yourself in one thing, pretty much like Java does, because Java is object-oriented all the way. It's a big commitment to get into Java for that alone. So anyway. Let's see what's this about.
It's time to talk about decorators, another key term in Python. And we've actually seen decorators before. Do you remember when we were building classes? I taught you that there was a class method and a static method. And I said, hey, don't worry about this. We'll talk about this later. Well, this is now later. Decorators look like this. They have the @ and then some sort of name following it. But in order for us to fully understand what decorators are, we have to talk about functions in Python and why they're so powerful. This is the neat thing about Python. In Python, functions are what we call first-class citizens. That is, they can be passed around like variables. They can be an argument inside of a function. They act just like, well, variables. Let me show you. If I create a hello function, which frankly is completely useless because all it does is say, hello. If I do this, remember what I said, functions are pretty much just variables in Python. Again, something that is not always the case with all programming languages. So
Yeah,
if
no,
I wanted to,
it's
I
not
could
the
say
case with
greet
Java.
equals to hello. So that if I print greet and I run this, I get hello. What if I
Well-
just pass hello like this?
Well, you execute the function and then print whatever it returns. So since the function is not returning anything, you are printing none. Okay.
If I run this, well, I get the function location in memory. So I'd have to use greet like this and run it, right? We have to call the
Yeah.
hello function. Okay, what if we do this? What if I say delete hello, a keyword in Python that deletes that function? What do you think will happen? Let's see. If I run this, is that what you expected? Did you expect greet to still work? The interesting
Well, yeah, because I guess that this might function just like a function, pun intended. I believe that just like in JavaScript, when you make an assignment to another variable with a function, in this case on line number 4, I believe that you are creating a copy of the function and you assigned it to the greet variable. So even if you delete the original function, you already back it up your hello function into greet. So yeah, if you try to call hello, you are not going to be able to because it's already deleted, I guess. And deleting functions is a new thing for me. I had never seen that in any other language, actually.
thing about Python is that I create hello, and this is now created in memory. when we get to line 4, I say, hey, greet is going to point to hello. So hello can still be called down here. I can still say hello because hello is the name of the function that points to that location in memory. But when I do delete hello, all it does is say, hey, I'm going to delete this function, this name reference to this function that's in memory. However, because greet, a whole nother variable, is still pointing to this function, I'm going to delete the hello word. So if I go hello like this,
it's not going to work.
Name hello is not. However, the greet is still pointing in memory to this location. So Python is smart enough to say, hey, you told me to delete hello. I'll delete the name hello, but I'm not going to delete the function because greet is still pointing to it. So functions in Python act just like variables do. They're first-class citizens.
Okay.
You can also pass functions around inside of arguments, right? If I say hello, and then this hello receives another function that calls, let's say, function, like this, well, I can create a greet function. Let's say define greet. And this function is just going to print still here. Now, in here, if I call hello with greet, or just so we're clear, let's just say a equals to hello greet. And if I print a,
oh, okay,
what will happen?
Yeah.
That still works. Because what happens is I say, hey, call the function hello. Okay, I'm calling the function hello with the argument greet. So we go here and we say, hey, run function. And what's function? We want to call this function, right? Because we have these brackets. So we don't know what function is.
You're returning a function.
So we go over here and say, hey, just print this. We didn't have to call it in here because the hello function calls it for us. So why did I just...
Wait a minute. That's actually important. So this is how the math function executes everything. Or any other function that takes, okay, font. And you just call it like there. Okay, so let me see. Line number 7 is going to call hello. Hello receives a function and it just calls the function directly. In this case, you are defining greet on line number 4. It's just printing something. And you pass greet as an argument to hello function. And that's it. A is going to store all of that. And you just print A. You are still trying to print a function which is value returns is none, but as part of the function you are printing still here because that's what's inside greet. Okay.
Teach you all of that. What does that have to do with decorators? Decorators are only possible because of these features. This ability of functions to act like variables, act like first-class citizens in Python. And when we start learning about decorators, underneath the hood, they're using this power of functions. Now, in the upcoming videos, we're going to talk about how to create our own, what they mean, and expand on this idea of a decorator.
Okay.
But here's a short form of what decorators do. Decorators supercharge our function. If we had our, let's say, hello function here, by adding some sort of a decorator, like this, we can supercharge our function and add extra functionality to it. It lets the Python interpreter know, I want this hello function to have some extra features. But let's explore this topic a little bit more in the next video.
What? Higher order functions.
Promise to not get mad at me, but there's actually one other thing I forgot to mention before we can talk about decorators. I know I'm building the suspense. I know you're just thinking, hey, Andre, tell me what a decorator is. You're wasting my time. But one more thing, quick video, I promise. We have to understand this idea of a higher order function. That is a higher order function, or HOC for short. Sounds super important, right?
Higher, yeah.
A higher order function can be one of two things. It could either be a function, let's say the greet function, that accepts another function. So this right here is
it's called the function.
It's a function that accepts inside of its parameters another function. Another way it can be a higher order function is if it's a function that returns another function. If we define, let's say, greet2 that just runs normally, but instead returns another function. So let's say in here, we have define func. And this define func, just returns 5. And we return the function. This is a higher order function. A higher order function is any function that either accepts a function
or returns a function,
or returns a function. And if you're thinking, hey, is that map function that we talked about, is that a higher order function because it is a function? Yep, that's a higher order function. So is reduce or filter. These are all higher order functions. All right, I promise in the next video, we're going to talk about why this is important and what decorators are. I'll see you in that one. Bye-bye.
Okay, decorators too.
Let's finally write our own decorator. Remember, a decorator supercharges our function.
Okay.
It's simply a function that runs another function and enhances it or changes it.
Hello. Okay,
it's working. So let's do that. Let's define a my decorator. And this decorator is going to accept a function. Right away, we should know that this is a higher order function. Now in here, inside of here, we're going to call the function. But before we do that, we're actually going to wrap this function in another function. So we're going to say define the wrap function. So this is just a wrapper. And this wrap function is going to be a function that simply runs this func. And then finally, we'll just return wrap function. And notice here that I'm not calling it. I'm just returning it so that later on, somebody can use it. Okay, now let's say we have a simple function, hello. And this simple function.
Okay, wait a minute, again.
Another function and enhances it or changes it. But the best way for me to explain what it is to actually code our own. So let's do that. Let's define a my decorator. And this decorator is going to accept a function. Right away, we should know that this is a higher order function. Now in here, inside of here, we're going to call the function. But before we do that, we're actually going to wrap this function in another function. So we're going to say define the wrap function. So this is just a wrapper. And this wrap function is going to be a function that simply runs this function. And then finally, we'll just return wrap function. And notice here that I'm not calling it.
Yeah, no,
it so
just returning the function itself.
Okay, now let's say we have a simple function, hello. And this simple function just prints hello. Where I use this function. Now, why is this useful? Because now I can use this as decorator. Python, as soon as we write an A in front of this, is going to say, hey, this is going to be a decorator. And the decorator, as long as we follow this syntax of accepting a function, having a wrapper function, calling the function, and returning the wrapper function, can be used. So if I do my decorator, see how it's all blue? Now, this decorator can actually be used on top when defining our functions. So if we want to use my decorator on the hello function, we use it like this. So that when I call hello next in my program, I click run, I get hello. Okay, I know what you're thinking. You're thinking, this is a complete waste of time, Andre. Why do you do all of that? I could have...
Okay, let me see. Let me think, actually. Let me think. Okay, there is a decorator, but I'm trying to figure out how do you define a static method or a class method like this, using this thing here. No, I don't know. Okay, play.
Decorator is going to accept a function. Right away, we should know that this is a higher order function. Now in here, inside of here, we're going to call just prints hello.
Yeah, I already saw that.
This is a complete waste of time, Andre. Okay. Why did I have to do all of that? I could have just done this, just define the hello, and that was it. I'm so confused. Well, here's the thing. What we just did with the decorator hasn't changed anything. It works exactly as expected.
Yeah.
What it allows us to do is that now we can add extra functionality. Remember how I said that decorators is a function, like my decorator, that wraps, that is here, another function, which is the function that we pass it, and enhances it. So how do we enhance hello? Well, we can do anything inside of this wrapped function. For example, I can say print, and then we'll just print some stars in here.
Yeah,
maybe print another set of stars in here. So that when I call run, boom, we've just super boosted our hello function. How cool is that? And this is why decorators are useful. By just adding this one line, I'm able to...
Okay, wait. It returned the function. Well, yeah. My decorator. But my decorator function is not calling the rat function in any way. Is that happening in the background? I guess that as long as I fulfill the requirements of getting a function as an argument, defining a rat function, executing the argument function, and returning the rat function, then I can use decorators. Yeah, I guess I don't think I have a use case for it right now, but okay.
Super boost a function. So that, let's say I create another function called buy. And this buy is going to print, see ya later.
Okay.
By calling buy here and clicking run, well, nothing changes.
Nothing changes.
Just like the hello, all I need to do is just copy the decorator and use it here.
Oh, so okay.
There we go. We've super boosted our buy.
Huh. Well, I guess that I might use decorators to comply with frameworks or to super boost functionality. Yeah, I guess.
This is the power of decorators. By just using this syntax, I can add extra functionality to other functions. Now, I know what you're thinking. I know I also keep saying that a lot. It's like I can read minds. But you're thinking, this is a lot of magic. How does Python interpreter do all of this? It's
yeah,
like
in the background, right? Maybe?
Underneath the hood, all it does, well, let me show you. Based on what we've learned so far about functions, because they're first-class citizens, right? All we're doing is literally this. We're saying variable A equals hello, and wrapping this hello and calling it with my decorator.
Okay.
So I'm saying my decorator, hello. And then after that, I'm running A like this.
Oh, okay.
So let's say this was hello 2. Well, I'm just running it like so. So that if I run this, everything still works. All I'm doing is wrapping my hello function with my decorator and assigning it to a variable.
So it's a shorthand.
We see that my decorator receives a function, in our case, the hello function. It then returns this wrapped function that has hello in here. So we return this wrapped function. So hello2 now equals this wrapped function. And then this wrapped function gets called. And what does it get called with? Well, it prints this, then it runs the hello function, and then it prints this. It's the same as doing something like this. We simply call it. Again, if I run this, it works. That looks strange, doesn't it? But
wow, what?
We're calling the first function, and the first function returns another function, and then we call the next return function.
We
which is
call it right next to it.
Now,
yeah.
the reason decorators are useful is because instead of doing this and frankly looking confusing, I can just add the @my_decorator, and we don't need to do all of this. Our hello is automatically wrapped by my decorator, but essentially this is what the @ is doing. See, nothing magic about it. Now, right now, this is nice, but I bet you're still wondering why decorators are useful. So in order to really finalize our understanding of decorators, let's take a break and I'll see you in the next video.
Okay, but give me a minute. I might like to exercise this just to imprint it in my brain correctly. Okay. Oh, wait. So let me think. Well, it's just because I already know it's going to complain about not putting anything there. So my question should be, let's create the decorator function first. Decorator example. My decorator. And it's going to receive a function. And then, that's the first part. I need a wrapper. Wrapper function. This wrapper function is going to receive the function parameter as an argument. Well, it's going to receive a function parameter, I think. Oh, no, I'm wrong. It doesn't require anything. I guess because it's already inside from this level over here, so I don't really need it. Yeah. And the print code over here. Oh, wait. I forgot about. There we go. Nope. And here I call the function. I make a function call. I need to return that. Wait a minute. It's going to run it. And I have to return this very same function. Wait. Return the wrapper function itself. And that's it. That's my decorator. Oh, wait. The return must be at this level. Thank you very much. And then I use let's try to use, I define a function saying hello. Okay, but I need to, okay, let's try first like this. Say hello. I don't receive anything. I don't return anything, I guess. I wonder if it's a requirement to do this. You know? So I can, I explicitly saying I'm not returning anything. So I guess that if I return true or something like that, that's going to be an issue because I'm not supposed to return anything. Well, I don't know. That's it. So I'm not using decorators here yet, so I can call it. Can I say hello directly? Let's see. Okay, so far so good. And now I'm going to try to use my decorator. Let's call my decorator. Okay. Okay, looks like it's working out. I'm trying to wrap my head around this concept. Okay. And I guess the other option was to say bye. And pretty much the same thing is going to happen. Okay. Okay, let's try again. Okay, so far so good. So I need... What the hell is this? Was this imported without my knowledge? Okay, let's help PyLinter to stop complaining about the stuff. Wait, what? There we go. Are you serious? Okay, that should be enough. Well, so I need 3 parts for this. The first one is going to be that I need to receive a function as a argument. I need a parameter here to receive functions. Then I need a wrapper, define a wrapper function inside, and here's where I'm going to get my my functionality down here. Okay, I adding functionality here. So this is the function that is going to be run in the end. Okay, it's going to execute whatever function I'm doing here. And then I'm going to return this very same function outside. That's the last part. Returning the function, higher order function. And then this decorator is going to tell Python what to do. Basically, it's a shorthand way to write what he described as assigning a function to a variable, then calling the higher order function, then calling back the whatever function I pass it. Okay. So it's a shorthand way to decorate function. Well, I guess the name makes sense now. I'm trying to wrap my head around this. I'm sorry if I sound stupid, but who cares? Oh wait.
Let me ask you a question.
Was I finished already?
Let's finally write our own. Now, this is nice, but I bet you're still wondering why decorators are useful.
Oh, okay.
So in order to really finalize our understanding of decorators, let's take a break and I'll see you in the next video.
Mm-hmm.
Here's a question. What happens if this hello function actually took a parameter? Let's say a
Oh, that's a good question actually.
greeting.
Yeah.
And a greeting was going to be printed here. Let's remove the by for now. Would this still work if I run hello? Pause the video and think about it. Let's find out.
Wait. No, it's not going to work because I don't see the greeting variable is not, there is no nothing bound to greeting at this time, I think. Well, literally it's going to ask for an argument and you are not giving it any. Yeah,
That's
it's going to break.
If you can, try to pause the video here and see if you can solve this. How can we make this allow arguments? I see that on line 5, right here, it says line 5, hello is missing one required positional argument, greeting. Because when we actually call hello, we're expecting to have a parameter, but here, we're not giving it any arguments. How can we solve this?
Well, you might pass a lambda function maybe. And because it's waiting for the parameter to be called as a function. So it's obviously you need to pass a function, and a lambda expression will be perfect for that, I think.
Well, the one way is to just simply say greeting, right? Or we can say whatever we want. We can say x. And then this wrapper function receives the parameter. So that if I click run, line 13 is now giving me an error because, well, now we need to actually give it a greeting. So let's say hi. If I click run, all right.
Okay, now, okay, that was not what I was thinking about. Okay, let's think about this. Let's play it back a little bit.
One way is to just simply say greeting, right? Or we can say whatever we want. We can say X. And then this wrapper function receives the parameter.
Okay.
So that if I click run, line 13 is now giving me an error because, well, now we need to actually give it a greeting. So let's say, hi. If I click run, all right, this.
Oh, I get it. You're just passing parameters to the wrapper function. Yeah, it makes sense. Okay.
And I hope this makes sense, right? We're calling hello with hi. So this function, hello, gets passed. We then receive as argument the X, right? Remember, underneath the hood, my decorator is saying A equals my decorator and hello.
Hello.
So all we're doing is running my decorator hello, which now turns into the wrap function. And when we do the wrap function A, we give it an argument of hi. So the wrap function accepts this parameter and then runs the function hello. But here's the question. What if greeting also had an emoji that it accepts? So we're printing greeting and then the emoji. What do we do? Well, again, we have to create another parameter and then another parameter and then here call it with, let's say, a smiley face. If I click run.
You need to enclose that as a string. Yeah.
But this is hectic. Every time I need to change parameters, well, I have to modify this. And what if we had keyword arguments like default hi?
Yeah.
There's actually a pattern here that we can use that makes things really, really simple for us. And all we do is this. We do the star args, which we have seen, which takes all positional arguments.
Oh, we're including everything.
Args, which takes all the keyword arguments. And we call the function by saying star args, all the positional arguments, and star keyword args to unpack all the keyword arguments. Now, if this looks confusing, don't worry. This is just a pattern.
No, it's okay because I already exercised that a lot. And actually, you are making this wrapper function very generic in the sense that you might send any number of arguments to the function when you are running it.
That you can just copy and paste and remember. But now, check this out. I can do emoji equals to, let's say, sad face as a keyword argument. And now, if I just pass hi like this and hit run, and let's just remove this as well since we don't need it. We'll call hello properly because we have the decorator, and then click run. Look at that. I get hi with the sad face. Now, the reason this is called a decorator, it's because it's a famous pattern in programming. It's called the decorator pattern. And this is the decorator pattern. It gives our decorator flexibility so that we're able to pass as many arguments as we want into our wrapped function. But using
we're looking design here.
Function. And this syntax, let's say if we didn't even have the print statements, this syntax is why decorators are so powerful. By just using these lines of code, we're able to add functionality using the decorator pattern to decorate our functions. And the decorator patterns are used all over programming. So it's a very, very powerful concept. To finish off the lesson on decorator, I want to talk to you about some of the ways that decorators can be useful and some of the common locations that we're going to see decorator patterns in our code. And we're going to build our own performance decorator that's going to be able to tell us how our functions perform, how fast they are.
Oh,
I promise you, by the end of that video, decorators are going to make sense to you. And you're going to be able to explain to other people and other friends why we should use decorators in our programs.
I don't think my friends, I only had one, are going to want to learn about decorators. But anyway.
Decorators. I mean, we've already seen them in classes, right? We saw how class method and static method. We're able to create class methods and static methods on the class that the direct class can use. If you don't remember these, just go back to those videos. But I want to show you one of my favorite examples of a decorator. We're going to create our own. What we're going to do is I want to have a performance decorator. And by the way, this decorator doesn't exist in Python. We're going to build it from scratch.
Oh, nice.
Is be able to have a performance decorator that I can use during testing my code to see how fast my code runs. For example, if I had a function, let's say long time, that takes, well, a long time to complete. So I'm going to do a really long loop and say for I in a range of, let's say, all these numbers, and I'm just going to do a random calculation, I times 5. This function, I want to know how well it performs, how many milliseconds it takes to complete this.
Okay.
How can we build that? First, I'm going to do something that we haven't talked about yet that we will. Something about modules and built-in modules. So for now, we're not going to talk about this too much, but we're going to import from the time
something.
Module, something called, well, time.
Okay.
Again, something that we'll talk about in the module section of the course. I'm essentially saying, hey, when I installed Python, or in my case, when I'm using this REPL, it has access to this time if I ask for it. And in this case, I'm saying, hey, I want to use this time object or module that
from the time library.
And in here, we're going to create our decorator following the pattern that we've learned. I'm going to say define performance, and performance is going to accept a function, just like we've seen before. And in here, we'll have our wrapper. So let's say wrapper function, and wrapper function, if you remember, it's going to be flexible by taking in star args and star keyword args, so that we can pass it however many parameters we want, because we don't know how this function, how many parameters it's going to have, and I want to be able to do performance on all my functions. Now in here, first, what we're going to do is we're going to have the result of the function be the function that we receive right here, and then simply say, run the function with star args and star keyword. And finally, at the end of this, I want to return the results. And then finally, we're going to return the wrapper. So nothing we haven't seen before.
Nothing wrong. Yeah.
Ran the function, but I'll show you why I did it this way in a second. Right now, our function doesn't really do anything.
Yeah, it's returning something.
Well, nothing happens if I do time and I run this function.
Yeah, it's going to take a while, but it's going to return.
Yeah. Nothing happens. This is when we make things interesting. We want to calculate from the beginning of running this function to the end of running this function. And we use the time module to do this. I can create a variable, time1 for the start, and simply say time. So I'm running this time function. That's going to start a time and say, hey, this initial time is going to be t1.
Okay.
And after this function, our main function, long time gets run, I'm going to say t2 and say, hey, what's the time right now? So this time, we'll check what time it's now. And then we're going to run this function. And then this time, it's going to check the time. And however much difference there is between these two.
The difference between these two.
Right?
Okay.
So all we do is say print an f string and say it
time 2 minus time 1.
t2. Right? And this actually returns in milliseconds. So I'll just say ms for milliseconds.
Okay.
And that's it. I've
those are milliseconds.
with just this extra time piece. And then I'm printing as soon as we run the function how long it took. So let's check it out. If I now run my long time function right here and I click run. All right, I get a minus number because I messed up here. This should be t2 minus t1. Because
yeah, t2 minus t1, yeah.
Passes, and then t2. So t2 is always going to be larger than t1. If I run this, right, it took 0.16 milliseconds. I think this is actually seconds. Now, let's make this long function even longer. If I go like this and click run, oh boy, that took 1.9 seconds. What if I make it even longer? If I click run, and this is the part where I keep talking
10 seconds
because there's going to be an awkward silence. Otherwise, hopefully this ends because I have nothing else to talk about. Come on, this is getting awkward.
It's 10 seconds.
I'm going to fast forward through here.
Okay, 19 seconds. Okay.
That's pretty bad. But I now have this decorator that I can give to pretty much any function in my program and actually measure the performance of my function. Pretty useful, right?
Just to see, wow.
And before, let's say, I deploy my code or put my code out into the world, I can test how performant my functions are. And maybe I can optimize things in different ways. Very, very useful. And I did that in just a few lines of code, 9 lines of code. Now, mind you, this performance decorator depends on the machine and how fast your CPU and memory are on your computer. So for what took me 19 seconds might take you a lot more or a lot less, depending on your machine. But this is a nice way to compare functions relatively. So I hope after this you see the power of decorators. Decorators are used a lot in Python libraries and frameworks.
Okay, he's saying goodbye right now. I wonder if performance decorator, is this, please tell me. There we go. Thank you very much. Yeah, I'm saving time here. Yeah. Well, I just copy that into because I believe this one here is going to actually be useful outside this course. Yeah. Long time. Okay, let's try Python 3 performance decorator. There we go. Well, if I want milliseconds, should I multiply that by 1000? Yeah, I need to enclose this in between parentheses, and then I multiply by 1000. So those are milliseconds. Wait, didn't work. Oh, did I did something wrong? T1 minus took. It didn't do anything. I wonder what let's see if maybe my math skills are really bad. There we go. Yeah, my math skills are really bad. Well, these are, yeah, I just multiplying seconds to 1000, so I get milliseconds, 1000 seconds. But I guess since I'm not getting, well, I think it's actually working. Yeah, I believe it's actually working. Yeah, okay. It took, what if I remove this? Yeah, it's actually working, just that it's so fast that it's taking just 0.3 milliseconds. Okay, so let's add a 0 here. There we go. And so it's actually working. So just as it's way too fast. That's the issue. There we go. 8 milliseconds. There we go. 8 milliseconds. And if I add one more, it's going to take way longer. 42 milliseconds. Okay, so at least my computer is fast. Okay. Okay, I guess I should Add decorators. Copy relative path. And another commit for this one. Yeah, I believe this performance decorator is going to be actually really useful. So I'm going to try to keep my mind on this one here, the performance decorator. That's going to prove to be actually useful. Okay.
Web frameworks that we're going to talk about, like Django and Flask, use decorators. Maybe you want to have some authentication decorator. So you do authenticated, where each function can only be run if the user is authenticated.
It's authenticated. Wow, nice.
Such as logging in to a website. Or maybe you just need
That's a good idea.
Or logging decorator that just logs and lets your database know that, hey, somebody has logged in.
Oh, yeah.
Hey, somebody has purchased something from Amazon. Or, hey, somebody just requested a friend request. There's so many uses for decorators. And decorator is a hard topic. You're not going to see them all over Python code. They're just an extra feature that you can use as you become more and more comfortable with Python. But I hope at the end of this all, you at least understand them to maybe one day build your own or use pre-built ones by libraries and frameworks. I'll see you in the next one. Bye.
Yeah, that's actually a good idea. Yeah, decorators are really authenticated. Okay, let's see the exercise. Let's have fun building exercises. Okay. Oh my God. No, thank you. Okay, let's see. Let's make an exercise. Okay, let's begin cleaning up a little bit. Wait, this is not even section 6. I am already on section 7, but I guess. Okay. Wait. Exercise. There we go. So what do we need to do? Okay, create an authenticated that allows the function to run as user1 is the function to run is user1 has valid set to true. Okay, that was a little bit confusing. Okay, create an authenticated decorator that only allows the function to run. Okay, I guess here should be if user1 has valid set to true. Okay. I need to code over here. Okay. And okay, so this is what I need to do. Okay. Def wrapper fund. Okay. And I'm going to need, when I'm getting called and receiving message friends, okay. Only run. Okay, let's open the performance decorator. Oh yeah, actually this is way better. Yeah. I don't know why I forgot about it. Yeah, I might receive any number of arguments and parameters. And yeah, no problem. And then the body, and I need to return something in the end. Okay. So I need to return or execute the function. In this case, it's going to be fn execute only if, and I wonder, okay, the function to run if user1 has valid set to true. So I have a dictionary here, and the valid key changes. This will either run or not run the message friends function. Okay. So I wonder if, okay, I'm going to run the function if, and I need to recover this user1 dictionary. Well, this function authenticated. This is the decorator here. Okay. The function needs to print this out. How do I get access to the user argument? That's my question. How do I get access to the function, to the user argument? So right here, I call this. He's using X for something. Let's use U. Or let's just use the same name, user. Well, that might be confusing. Let's use U. Okay, I'm going to message friends. Well, message friends user 1 is already the function itself. Okay, so let's check out performance decorators. There we go. This is the wrapper function. Okay, it's calling this. Okay. It's calling the whatever the wrapper function is going to need. Okay. Down here is the decorator. So the function is going to run just like this. So I need this as my list of copy. I need this. You need to run just like this. If, and here's the thing, user 1. I wonder how do I choose the... I need to interact with this one here. I need to recall how to use arcs. I already forgot actually. Okay. Okay, authenticated function. I had my wrapper. The wrapper receives any number of arguments. And I use them here. And how do I ask for this? How do I use arcs? I already forgot about it. Wait. I might. Arcs. This comprehension. Yeah, I don't think I have it here. Yeah, I am confused actually. Okay, let's see. Let's think. I need to say something in the like okay, let's Google about arcs. There we go. Yeah, I might ask for any number. The other function getting called like this. This is going to positional arguments. Non-keyword arguments. Okay. I might need this one here. Keyword arguments, but let's see. Other and any number of arguments. And it's a collection. Okay. Yeah, I forgot about it. Okay, this is a collection. And I might use this num. I get a single element and I can do some stuff. Okay. Okay, so first, this is the wrapper function. Let's not be confused. What happens with the performance decorator? In the case of the performance decorator, I'm just using this in order to pass any number of arguments to the function. Okay, this is not using anything. But Okay. Then I calculate the result. Okay. Let's think about it. Yeah, I don't know what to do here, but let's find out. Let's figure out. Okay, so the wrapper function is here. I need a way to access user one. So maybe for let's say for user in a particular in the arcs, or maybe in this case arc in arcs for an individual argument in arcs. I wonder if I need to. No, I can just refer it to like a normal variable. Okay, and then semicolon, and now I need to ask. Okay, arc. That's my wrapper function. No, that's my actual function. Wrapper. Well, my actual function is this one here. However, arcs is going to be the parameter. In this case, the dictionary. Okay. Arc dot. No, it's the index is like this. Valid. Wait. Okay, so this is the value. It's going to return true or false. So this is the if statement per se. If argument is valid, then run the function. Or actually, I may use this as a ternary. Okay, let's try to run the function fn if argument is valid, but here is missing something. What are you missing? Else is required. Is that required? I think it's stupid, but anyway. If run the function. There we go. I wonder if this is the answer. I'm not sure really. I think I'm confused right now, but let's see. Okay, def authenticated function. I receive a function here. I get this wrapper around here. And I need to return. I need to return result. Do I need to return something here? Yes, the wrapper needs to return the wrapper itself, I believe. I am confused right now, so it doesn't matter. But this needs to be here. Thank you very much. I don't need this to return anything else. And just conditioning the printing of this thing if the user has one. I don't think this is going to work, but anyway. Yeah, let's see. Let's try to run it. Maybe we may actually... Yeah, I'm not understanding this correctly. That's for sure. Exercise. Wait, is there something else? Exercise. Oh my god, I do have a... Yeah. Yeah, I have a typo somewhere here. Okay, let's fix that one. I wonder what's the right way to write exercise. To type it. I mean, it is here. Let's see. It's exercise, no C. Okay. Okay. It doesn't use any C's. Okay, there we go. Exercise. Decorators. No, it's not decorator. Yeah, decorators. Okay. Message friend missing one required positional argument user. There we go. So that's the part I'm missing here. Okay, user. So that's the part where he fixed it in the video, in the previous video. Okay. So I guess right there, I need to, he was using X. And in this case, I should not be using X. Why not? Because this is the function message friends user1. When I call this, yeah, I'm guessing right now. I don't really know what I'm doing here. Yeah, it's not defined. Let's try to rewatch the video. Right over here.
So let's check it out. If I now run my longtime function right here, and I click run, all right, I get a minus number because I messed up here. This should be T2 minus T1 because the time on T1.
Oh, wait, now before that one.
Be larger than T1. If I run this, let me ask you star by saying star args to unpack all the positional arguments and star keyword args to unpack all the keyword arguments. Now, if this looks confusing, don't worry. This is just a pattern that you can just copy and paste and remember. But now, check this out. I can do emoji equals to, let's say, sad face as a keyword argument. And now, if I just pass hi, like this, and hit run, and let's just remove this as well, since we don't need it. We'll call hello properly because we have the decorator, and then click run. Look at that. I get hi with the sad face. Now, the reason this is called a decorator is because it's a famous pattern in programming. It's called the Decorator Pattern. And this is the Decorator Pattern. It gives our decorator flexibility so that we're able to pass as many arguments as we want into our wrapped function by using star args and keyword args and then unpacking them like this inside of a function. And this syntax, let's say if we didn't even have the print statements, this syntax is why decorators are so powerful. By just using these lines of code, we're able to add functionality using the decorator pattern to decorate our functions. And the decorator patterns are used all over programming.
So this is what I need to actually write, to type. Yeah, that's the basic decorator pattern. Let's see. Let's remove this. And let's try to replicate that. My decorator function, the authenticated function, okay. Now we need to define the wrapper function. Def wrapper, okay. It's going to ask for arguments and keyword arguments. Args and keyword args. Okay, so far so good. And then call the function with such args. And pretty much the same parameter list. There we go. And that should be enough. I return the wrapper itself. And this is the decorator pattern. I'm not doing anything yet. So I wonder if I can just condition this by asking, but how do I get this? How do I, because here I can, okay, I think I'm close to it. I'm going to run this. Okay, now I need to ask if user1 has a valid key set to true. If that's the case, I'm going to run this line over here. So that's what I'm trying to do. If else, I don't know, false, whatever. If, I wonder how. Yeah, this is the wrapper then. Okay, let's see. Let's keep watching.
Very, very powerful concept. To finish off the lesson on decorator, I want to talk to you about some of the ways that decorators can be useful and some of the common locations that we're going to see decorator patterns in our code. And we're going to build our own performance decorator that's going to be able to tell us how our functions perform, how fast they are. And I promise you, by the end of on this, I can give to pretty much any function in my program and actually measure the performance of my function. Pretty useful, right? I could have this piece of code, and before, let's say, I deploy my code or put my code out into the world, I can test how performant my functions are, and maybe I can optimize things in different ways. Very, very useful, and I did that in just a few lines of code, 9 lines of code. Now, mind you, this performance decorator depends on the machine and how fast your CPU and memory are on your computer. So for what took me 19 seconds might take you a lot more or a lot less, depending on your machine. But this is a nice way to compare functions relatively. So I hope after this you see the power of decorators. Decorators are used a lot in Python libraries and frameworks. Web frameworks that we're going to talk about, like Django and Flask, use decorators. Maybe you want to have some authentication decorator. So you do authenticated, where each function can only be run if the user is authenticated. Maybe they have the privilege to run a function such as...
Well, in this case, it's running the function. It's doing its thing. I just want to know. Wait a minute. Maybe I can use the math function to execute something conditionally. You know? Yeah. I think that's the key. What happens if... But it's going to complicate things. Yeah, maybe I'm just wasting time. Maybe I should just see the solution. Okay, so let's see. This is the wrapper function. Now, this is cheating. Okay. Well, he's asking if the first element has a valid. Well, I guess. Then return the function with keyword args. So what he did here was, well, I guess it's cheating too. Well, he's asking basically, you know what? I'm going to assume that my first args element is going to be exactly something that has going to have an index of valid inside, so a dictionary. And if I had valid, I asking this thing is going to have false or true or false. If this thing evaluates to true, get the value of the Boolean value right now from this place. And if it's true, then return the function with the keyword args. And then I guess this is the thing I'm missing here, I guess. Is returning a function with a list of arguments. And then it returns the wrapper. Okay. Let's see if this runs. Yes, a message has been sent. And if I say false, it's not going to do anything. Okay. Define authenticated function. Then the wrapper. That's the second part. Then the third part is returning a function. In this case, the wrapper function itself. It's going to receive args. It's going to receive keyword args. And it's going to say, okay, if the first argument 0 has a key called valid, then get that value and evaluate it in an if statement. Okay, if this thing is true, then return the function itself with the list of arguments. In this case, it's going to return this very same function, message friends, and print out the message right down here, and that's it. What this decorator is doing is asking if the user is valid. Basically, if the user is authenticated, then do the thing. If not, well done. That's basically it. I need to study this clearly because I don't really get it that much. But anyway. And I think we are done with the chapter though. Yeah, we are done with the chapter. Okay, at 9 p.m. There we go. And 1 hour. Well, tomorrow I'm going to continue learning Python. Error handling, that's going to be another fun one. It's a very short one, actually. Well, I do have experience with that, with error handling in every other programming language and a scripted language I've been working on, but HTML, no. I don't think we need try-catch blocks in HTML. I don't think so. But anyway, well, thank you for coming in if you indeed are, and see you next time.